Hello and welcome to the Side1 YouTube channel. My name is Ray, and in this video we're unboxing a new tablet oscilloscope. So this is made by FNIRSI. Not sure exactly how you pronounce that, but that's my attempt. This is a 4-in-1 multifunction tablet oscilloscope. So it's an oscilloscope, a signal generator, a frequency response analyzer, and a spectrum analyzer. The model number here is DPOS350P. So let's have a look at this. This actually arrived a little bit quicker than I expected. There's a heap of specs on the back, and I will try and get a list of those and put them in the description as well. And it set me back just under 400 Australian dollars delivered. So let's open up the plastic. Come shrink wrapped, as well as a nice solid cardboard box. The supplier who sold it to me, and I bought this through AliExpress, had it wrapped reasonably well for shipping. And it actually arrived faster than one of my orders from within Australia. So it's a 350 meg, 1 gigasample a second oscilloscope. It's in 2 languages on the box. I'm assuming that's Chinese as well as English. Manufactured in Shenzhen, which is pretty common for a lot of the Chinese technology. And they do have a QR code, so you can actually go and download the manual. I did actually download the manual, and 22 pages of that was in English. Okay, so inside we've got a case. Very nice case, actually. And box has small packing in it, but beyond that there's nothing else in the box. So I'm just going to move that out of the way. And it's a zipper. There's actually 2 zippers on it, both on the same side, so let's open it up. On the back side there's nothing really showing. Handle on the top. Alright, so in here we have a plastic bag inside a pouch, and we've got 2 probes. Now these are 350 megahertz probes, and they support 10 times and 1 times resolution. And there is a probe characteristics sheet in here as well. Which is important information when you're looking at high frequency stuff. Most of what I look at is low frequency, but modern electronics these days are getting up over 100 megahertz. So for the digital electronics with microcontrollers, so it's handy to have something that'll go up to 350 megahertz. We have a little adjustment tool to adjust the trimming capacitors that are in the bases of these to improve the squareness of your signal, and little rings that you can put on both ends, the probe and on the BNC, to help identify them. Alright, let's have a look and see what else we've got in this pack. USB-C. This one's showing orange. I believe that means high current. Yes, 6 amps. It's got written on the unit. We've got another test lead. This is BNC one end and a pair of alligator clips on the other. And we have a USB charger. Now this is European standard. The options I had when I was ordering was either European or US. Neither options worked for me, but I do have an adapter that lets me plug the European in or the US. I actually chose the European because I think I've got another adapter around that supports European as well. Right, on the other side we have a protective flap, and in that we have the manual. And the manual looks very much like the one I downloaded. So our contents, this is our English section, goes down to page 25, and then it says last page. This next language, I'm not sure what that language is, but it goes from 26 down to 51. And then this one is 52 to 78. Now it does go into a few safety things and also response things on the front in the introduction. So it does tell you if you're doing very high frequency work, use the 10 times probe. It'll actually put less loading on what you're testing, and so will give you a better result. So it does pay to actually read all of this manual, which I haven't actually done as yet. It's a 2-channel oscilloscope, and it will support 1 times 10 times or 100 times attenuation. 350 megahertz, 1 nanosecond rise time, 1 gigasample a second, 60,000 points is its memory depth, impedance of 1 megohm, 14 PF, so they've actually given the capacity value as well. Time base range is 5 nanoseconds through to 50 seconds. Roll time base 50 milliseconds to 50 seconds. Vertical sensitivity 2 millivolts per division to 20 millivolts per division on times 1. Increase that for times 10 and times 100. We've also got 16 millivolt to 160 volt at times 1 for vertical range. DC accuracy plus or minus 2%, time accuracy plus or minus 0.01%. Input coupling is DC or AC. It's high resolution mode, 8 to 16 bit. Parameter measurements 12 types. So it's actually got a fair bit in here. And then we go into the other functions that it has, like the signal generator. 0 to 5 volts peak to peak amplitude with an offset voltage of 2.5 volts plus or minus. And it'll go up to 50 megahertz sine wave. So that's not a bad little unit. 0.1 to 99.9% duty cycle. Frequency resolution is in 1 hertz. Amplitude resolution in 1 millivolt. Offset resolution in 1 millivolt. And duty cycle resolution 0.1%. Customizable captured waveform 500 groups. From the frequency response analyzer, 100 Hz to 50 megahertz, excitation signal amplitude 0 to 5 volt peak to peak, excitation signal offset minus 2.5 volt to positive 2.5 volt, and excitation frequency count 20 to 500. So this thing actually has quite a lot of features into it. The languages it supports: Chinese, English, Russian and Portuguese. It's a 7-inch screen with a resolution of 1024 by 600 pixels, and it's a capacitive touchscreen. Automatic shutdown is 15 minutes to 1 hour, or you can actually turn that off. Support ISO image upgrade. Now there was something in the notes about it if you're going to do a firmware update on it, and there is a firmware available for it. Make sure you do it using Windows. And the rest of the manual goes through describing all of the features and functions and how to use it. So it's actually one of the better manuals that I've seen. There is a lot of information in this one. And there's also a frequently asked questions. And then it ends on page 25 with a contact us. Okay, so inside here we have our quality control tag. I found that in every one of the products from this company. And then in the bottom here we've actually got a tablet. It's currently wrapped up. So it does have a lithium-ion battery built in. And I'm having trouble opening this. Here we go. And this case is now empty, so I'm just going to move it to the side. Alright, so on the top side, got little covers over the BNC for channel 1, channel 2, and our signal generator output. And it's actually quite a beefy little unit. 35mm deep. Approximately 130mm high. And I'll have to go to a bigger bigger measuring stick. 195mm wide. On this side we have a USB port and our power button. There's nothing on this side, nothing on the bottom. There's a few cooling holes. There's little rubber pads here and here. On the back we have a kick out stand. That's why these rubber pads. It's actually got a little bit of weight in it. $747 grams. So there's a little bit of weight to it. Let's turn it on. So push and hold the button. It all lights up on both sides. And we get our display. Now if I take one of our probes, we do have another signal generator for 4 to 20 milliamp and 0 to 10 volt. I should have probably brought that home with me. Now, normally on these things, well, there's a fan in this, I can feel it. On the back, just here is a fan. So it must be drawing air in through here because it's exhausting out the back here. Okay, I've had a little bit of a play around with this and I've gotten to understand how this works now. So what I have here is a servo tester. This is just a simple device that produces a pulse width modulated signal, in which this case the pulse width determines the position, and we can actually change the frequency of our pulse width while maintaining the microsecond width of our pulses, which is standard for servo control. At the moment I've got this set at 1500 microseconds or 1.5 milliseconds, and I've worked out how to actually use this to read all of that information. So I've got channel 2 turned off at the moment, and I've programmed in our readings down the bottom here. might actually take a screenshot of that and I can superimpose that on the video when I'm editing. Because channel 2 is off, everything in the top row of our data information is turned off. Now we can actually change that with our measure button up here, and it actually puts it in the order that you turn the features on. So I turned on everything I wanted for a full row on the channel 1, and then I repeated the same order and the same settings on channel 2. And that works for me. We do have Vmax, Vmin, Vaverage, VRMS, VP, I believe that's VPeak from 0, and peak to peak voltage. Peak to peak for me is more relevant. F is frequency. T, I believe, is the time period. So if this had come out to exactly 20 milliseconds here, that'd be 50 hertz. T plus is how long the voltage is above the trigger line. And there's a reason why I'm specifying it like that. T negative, I believe, is for below the trigger line. DU is the percentage it's above that trigger line, and DU minus is the percentage below that trigger line. So pretty straightforward and simple, easy to set up, and it does the automatic measurements. Now, one of the things I did find, you can zoom in, which shows this quite nice, and you can do measurements with a cursor, but it's counterintuitive here. Those measurements are actually on the original signal at the top and not on the zoomed in value. So just something to be aware of. I couldn't make heads and tails of it earlier because I was trying to measure on the bottom part on the zoomed signal, and it doesn't do it. It actually measures on the top unzoomed signal. What you can do though is tapping on this side changes the time base, and tapping on the other side changes, goes down through the time base. Here you have channel 1 is listed at the moment. Clicking on it will change it to channel 2. I'll switch it back to channel because I'm just using that at the moment. And pressing the plus or minus changes your voltage. Setting 50% sets the, or hitting this 50% puts the trigger halfway between the signal minimum and maximum. So I'm just going to put that back to where it was. We also have the auto setup, which is the A button over here. It works really well. So I'll just demonstrate that now as it goes through the process of setting the time base as well as the voltage level settings for the inputs. I'll just turn off my cursor. Up here we have a save wave and save screenshot. Now the save screenshot basically captures the image we're seeing right now. Save wave takes a copy of the entire wave, and we can actually go back through and make measurements using the screen when we go back and look. So I'll save a wave, and we can come back to function. No, sorry, system. Browse. Alright, so browse a waveform, and I've done this a few times. And here we can move along and we can take measurements. Now, the trick here is this H1, H2 is actually looking at up here, not down here. So I'm going to turn the zoom off. I'm going to move this to that point, move this to that point. And there we can see our rising time by taking a measurement. And the difference is 263.2 microseconds for the rise time. And that's looking at a captured wave. Turn off our cursor. Go back to our channel 1. Now, you can save your configuration or even read your configuration. So by doing that, I've reset all of my settings down the bottom here. Now the move down here, you've got slow and fast. That allows you to change the rate at which things move. So in fast, things will move quite quickly. If you set it to slow, things move slowly as you move, which is handy for fine adjustment. So that's the basics of it. The channel button down here lets you set your attenuation times 1 times 10, and this one will support a times 100, which I don't have yet. The coupling mode is either AC or DC. It does have an FFT display, and you can see that come up here. It doesn't give me any meaningful measurements, but it looks pretty. Turn that back off. And then we have our bandwidth limit, which is basically what we're measuring at. At the moment, I'm using the full 350 meg. I can go out to 20 meg or down to 20 meg, and that increases the bandwidth a little bit. You've got the same for channel 2. I've got channel 2 turned off at the moment, and I will turn that back on in a minute when I demonstrate some of the generator. Horizontal lets you select the time base. So I've got it set at 5 milliseconds. You can go smaller or bigger. Again, you can do that on the sides of the screen here as well. Change up and down, and it tells you what you've got set down the bottom here. Now this thing is telling me it's running. Pushing the pause button here freezes the display. It also tells you what resolution you're running at as far as the voltage capture. So if you're doing settings up high, like 350 megahertz, sometimes it pays to drop back to 8-bit. It also helps when you're doing Fourier analysis and the like to work with lower resolution. Okay, so let's have a look at the signal generator. So for this, I'm going to turn off channel 1, which was looking at this. Oh, just before I do that, just to show that this does change. Just going to auto reset. So you can see here we're running at around 2.2 milliseconds or 2,200 microseconds. And if I turn this down, we also get the same down here at 800 versus 800 here. So it actually works quite well. I'm actually quite pleased with the way that works. All right, so I'm going to turn that off. Turn off channel 1, turn on channel 2, rerun auto set. So this is generating a square wave 1 kilohertz signal at the moment with a duty cycle of 50%, and it is actually telling me my frequency is 1 kilohertz, my RMS voltage is 50 millivolts, Let me just check something. That's better, 504 millivolts. The switch on my coupling here, connected to the signal generator output, is at 10 times, so I just needed to make sure that matched. We can again change our setting. Our peak-to-peak voltage is 1 volt, and the time base is 999.7 microseconds, so close enough. All right, let's have a look at our signal generator. So if we click on down here, we've got our generator. It's currently square. Clicking on the waveform, we can actually select a series of waveforms. So we've got sine, square, triangular, sawtooth 1, sawtooth 2. One's a forward and one's a reverse sweep. Then there's step, which gives you a stair step on a sawtooth. Half sine wave. So if you were measuring from a half wave rectifier, so a single diode from an AC source, this is similar to what you would get. Full, in other words, through a full wave rectifier. Exponent, and ringing. So you can generate a few different signals. There is, I believe, a capture, so you can actually capture a signal and save that, which is cool. DC, sine C. This is an interesting one. Multi-sine and a square root. So let's go back to our square wave. You can set the amplitude, the frequency, the offset voltage, and the duty pulse width. All done through here. So select on the one you want. Use the arrows to select the digit you want to edit. And use the up and down buttons to change. And you should get something very similar on your feedback on your readings. So this has got a duty cycle of near enough 55% after making that change. So it is actually very easy to use. I found that it's reasonably intuitive. Apart from that zoom with the cursors, I found it is reasonably intuitive. Now, the other thing I found is under function, we do have a spectrum analyzer. And what I found with the spectrum analyzer is it will pick up a lot of noise. It isn't picking up the base frequency that I would normally use, which is mains frequency. But if I clip the earth onto the tip of the probe, and there is an auto setup on this, and if I move this close to my light, it's using channel 1, I think. Oh no, it's using channel 2. Yep, it is using channel 1. Okay, so if I move this close to my light I've got above my desk here, it's got a switch mode power supply to drive the LED. If I turn it off, I'll turn it up. If I turn it off, you can see that drop. I'm using 0 to 500 meg. I'm going to drop that down to 200 hertz. Puts it back to megahertz. But you can see the interference occurring at that low end. Actually, no, let's go 100 kilohertz. But yeah, you can see the interference that is occurring. If I turn on the 3D display, you can see the signal there, and as I move the probe away, you can see the general noise come back. And we also have a waterfall display. So, interesting feature. Overall, it is very easy to drive. Triggering, I thought I'd better cover that one. It's set to auto by default. You can do single shot, you can do normal, which means it'll trigger basically what it's doing auto at the moment. You can trigger on a rising or a falling edge, and you can select either channel 1 or channel 2 as your trigger. Of course, I got channel 1 turned off here, so it's going to trigger on channel 2. And it does have a few other features as well. Background grid you can turn on and off. I found it better with it on. You can actually read it. If you know what your divisions are on both your voltage and your time base, you can actually calculate frequency, etc. So that's our square wave. And set our trigger at halfway, and that'll clean it up. Alright, so it's actually very easy to use, really. Compared to some of the other meters or oscilloscopes I've used, it's actually very easy to read. It's a good size screen. And it is actually very easy to configure what's going on. The oscilloscope I used to use as my go-to was this thing. I've had this for many years now, a little DS203. And by comparison, this is a lot easier to set up. This doesn't really have the auto setup feature that this one does. And that auto setup works really well. I think this one was actually a good buy, and I actually would recommend it. Only thing I would like to see added to it, if at all possible, is something that can interpret digital signals, similar to what you can do with a logic analyzer. I have seen some oscilloscopes that have that feature where they can decode a digital signal. That would be a nice to have. And something like this as a logic analyzer would also be a nice addition if they make one. I haven't seen one in their catalog yet, so that would be a recommendation for them to try and make one. They do sell a high voltage probe with a 100 times attenuation on it, so I might get one of those in. They're not that expensive from their site. If I get one of those, I'll put out a video on it as well. If you like these videos, don't forget to click on like, subscribe, ring that notification bell. It's a form of support, helps the channel a great deal, and costs you absolutely nothing. If you'd like to support the channel further, I do have a Patreon and YouTube membership accounts, and you can join my VIP patrons Go Lucky, Jeff Jerd, and Caress Cortani. My builder patrons El Morales 45, Andrew Cardone, and Agar 69 in helping to support the channel. I do release all my videos about a week early before YouTube, so my patrons can see them early. If you've got any questions, feel free to leave a comment below or drop into the Discord. There will be a link below, and you can leave a message there and myself or someone else may be able to answer your question. And we'll see you in the next video.